Hello students, I am Dr. Anita Sharma and in my today's lecture I am going to explain Introduction of Spectroscopy and Electronic Transitions in UV Spectroscopy. So let's begin.
Ultraviolet Spectroscopy, Paper 304, Unit 1. The spectroscopic technique forms the largest and most important single group of techniques used in chemistry. Spectroscopy and its application form a single part of modern chemistry. So, we will begin with the definition of spectroscopy. Spectroscopy is the branch of science that deals with the study of interaction of electromagnetic radiations with matter. Now, electromagnetic radiations consist of discrete packages of energy which are called photons, a kind of radiations including visible light, radio waves, gamma rays and X-rays in which electric and magnetic field vary simultaneously. This is the figure of electromagnetic radiations where you can see magnetic field is perpendicular to electric field. Now, properties of electromagnetic radiations. Frequency. The number of complete wavelength unit passing through a given point in unit time is called frequency of radiation and it is generally expressed in cycle per second or hertz. Wavelength. It is the distance between two successive crests or troughs of a wave and called wavelength and it can be expressed in meters, centimeter and angstroms. Velocity, the distance traveled by a wave in 1 second is called velocity of wave and it is denoted by V or C. Wave number, it is defined as the number of complete wave cycle per unit of a linear space. It is usually measured in unit of reciprocal centimeter and reciprocal meter. Now some advantages of spectroscopy. Spectroscopic methods are much more rapid and very less time consuming. They give information which is recorded in form of chart. Very small quantity of compound is required. Structural information gained by spectroscopic method is much more precise and reliable. There are two principal classes of spectroscopy. First is absorption spectroscopy, an analytical technique which concerns with the measurement of absorption of electromagnetic radiations. UV visible and IR spectroscopy are the example of absorption spectroscopy. Emission spectroscopy is an analytical technique in which emission is dispersed according to some properties of the emission and the amount of dispersion is measured. Mass spectroscopy is the example of emission spectroscopy. Now UV. The UV radiations region extend from 10 nanometer to 400 nanometer and it is subdivided into two spectral regions. Region between 200 to 400 nanometer is known as near ultraviolet region. Region below 200 nanometers known as far or vacuum ultraviolet region. The common solvent used for preparing sample to be analyzed is either ethyl alcohol or hexane. Electronic transition, which is the most important topic, could be asked in exams. The UV radiations has sufficient energy to excite valence electrons in many atoms or molecules. And three distinct types of electrons are involved in organic molecules. They are sigma electrons. These electrons are involved in saturated bonds. Pi electrons, they are involved in unsaturated bonds. And N electron, these are the electrons which are not involved in bonding between atoms in molecules. The possible electronic transitions graphically shown as sigma to sigma star transition, pi to pi star transition, n to pi star transition and n to sigma star transition. Sigma to sigma star transition. Sigma electrons from bonding orbital is excited to corresponding anti-bonding sigma orbital and the energy required for this transition is maximum. Example methane, which shows absorbance maxima at 125 nanometer. Pi to pi star transition, pi electrons in bonding orbital is excited to anti-bonding pi orbital and example alkenes which generally absorb in the region 170 to 205 nanometer. N to sigma star transitions, saturated compounds containing atoms with lone pair of electrons like oxygen, nitrogen, sulfur and halogens are capable of N to sigma star transition and the range of N to sigma star transitions 150 to 250 nanometer. N to pi star transition, an electron from non-bonding orbital is promoted to anti-bonding pi orbital. N to pi star transition required minimum energy and show absorption at longer wavelength around 300 nanometer. Now you can see the resources. Thank you.